So NetConf is a bit different from the OpenFlow in that this is a Yang modeled protocol, capability driven. So in order to, so really you could think of the NetConf if you worked with the MDSAL. Who of you here worked with the MDSAL? So NetConf is practically remote MDSAL. You could view NetConf as that. That would be better. We'll use that. Okay. So NetConf is as a remote MDSAL. So in order to achieve the NetConf clustering, you actually need to achieve remoting of MDSAL itself, or to have a basic support for remote MDSALs. And there is the other way how to solve that. The one way which Moiz was thinking of is to have actually full mesh connectivity of in the free node cluster, that each node is connected to each NetConf device. Okay, so, Mike, and explain yourself.
I'll tell you what I was thinking. So essentially
Hello.
Okay, this is on. So what I was thinking of, I mean, it doesn't have to be like this. I just drew it this way. So you could have a fourth node over here, which is not connected to that NetConf device at all. But, well, actually, I think, sorry, no, it was full mesh.
Yeah, it was full mesh since we are free node. And given that the RESTconf, you connect to any one node, you have always the accessibility to the device. That's the one solution to the problem. The second one, which I heard, is actually to do the proxying. So you don't have a full mesh connectivity, but internally we will load balance your request or forward your request to the node which is connected to the actual device. But has the pros and cons. Currently, how the MDSAL amount points and NetConf works, full mesh connectivity is easy win for some of the use cases. For the use cases where you are just configuring the NetConf device, reading the operational data, this will be easy win. This will be easy in, so we'll just sync configuration. We will just sync the configuration, and every node will connect to the network device. Given that the NetConf itself was very optimized for high scale, this shouldn't be a problem. Single node audio instance is able to handle 10,000 sessions per single node. So having a full mesh there isn't a problem. The problem actually with this solution is only if you start to listening and subscribing to the notification events. Because having that, or not?
Actually, who's doing that?
No, there will be a problem because it will be delivered in the local controller. So yeah, that's probably the solution. In the proxy will be harder. There are applications who are actually doing that.
Getting notification. How often do those notifications come in?
It depends.
Because once you start receiving notifications,
How often you are receiving notifications in your apps from the NetConf?
It's only a few a second, but I know there are people out there who want to run stats.
So the problem is when something happens in a device, then you get a burst.
Yeah.
And it's at the least appropriate time when you start getting a lot of notifications. And that's the case that we have to design for.
So it's much more like burst, nothing. Burst, nothing.
Times when the network is unstable, when all kinds of other crap is going on, so we've got to get good performance there.
so when we talked about scalability, that we can actually do 10,000 devices per controller, what happens when we get notifications like that? The bursting notification.
Does NetConf node send the notifications on all three connections or all the
It would be only on one connection.
On the connection on which you subscribed. So you could actually do that.
We do need to split the subscription for notifications across different nodes.
Which is fine.
Yeah, which makes sense.
First line of defense.
Yes.
So when you're defining this architecture, you're going to not just specify how many nodes you want to support, which is cool.
But
You have to support
what throughput I want to support?
traffic model.
Yeah.
There's going to be a burst, a max burst that you got to support, and a sustained rate, right?
Yeah.
Sustained is trivial. Everybody can do that in their sleep.
Bursting is killing JVMs usually.
How long that burst is going to be.
What we started doing is actually send telemetry as events up from the connection into the control, and that can go from every node every couple of seconds.
Well, that reminds me. So I don't know if you remember to write this down from last year, but Margaret Cozy from AT&T mentioned that from every switch, every 5 minutes, you have to download all the statistics, right? And so that was really their bottleneck. So
Yeah,
that has to be
rather
optimized.
than downloading the statistics every 5 minutes, you actually send statistics every 5 seconds on the NetConf connection and notifications up to the control.
Every 5 seconds. Okay. Not 5 minutes.
Yeah, every few seconds.
Yeah, but that depends on your NetConf vendor.
Statistics, but sunset and rotate over the few seconds.
Yeah. But that is dependent on your NetConf vendor.
Yes.
That's true.
So I'm just saying, we're trying to come up with an architecture without knowing the requirements. It's really weird.
Yeah.
Right? So are they captured? I don't know, because I apologize.
So for the NetConf, the requirements are mostly coming from Jan currently.
I think in this case, the requirement is simple, right? You mount a NetConf device from one controller instance, and you should be able to access the RPCs and the data from any other instance in the
Right.
Right, but
basically the
how do
requirement.
I judge whether the architecture is correct without knowing what rate I have to sustain? We can't.
That, of course, we have to see, but here we are trying to just make sure everything is accessible in the first place.
Yeah, but there's pressure points for an architecture, right? So if you know what the traffic model is, you can actually compute a real architecture. Just saying, I mean, should use the word real, I guess. But I apologize.
No, that's where, Moiz, remember I was talking to you. Can we delegate this proxy to be outside the controller so that it can scale in its own way?
So delegating the proxy outside the controller, you are thinking about having 3 nodes here which are working with the network devices, and you have 3 nodes here which are doing the applications.
No, down below when it be NetConf or even Moiz plugin, you have a,
As an external process to the controller.
yeah, which is like a gateway managing the pool of connections to these switches, and in that way it can scale.
That
Because what will happen in this particular case is one of the nodes is a proxy, and if that is getting overloaded and if that fails, then you have to transition to other nodes.
Yeah.
And that transition takes time and it kills all other nodes.
so
Just say if you're building a service tunnel, right? You want to have a tunnel proxy separately, not as part of your controller itself.
so basically, what do you mean in the term of the controller is,
It is talking to a gateway. We can talk.
and that gateway is, because actually, given the SDN,
Gateway or it can be a OF gateway.
yeah, I'm trying to figure out your terminology, because given the SDN, for some people, controller is the gateway to connections. For some people, controller is the applications which are using these connections to inject some state into the network. I don't like term controller. They are just applications. Everything is just an application and how they interact. So if I understand your model correctly, it's more like I have a 3-node cluster of controller plus application here. And I have here some gateway, maybe in HA mode or standalone mode. And controller is accessing that gateway, which is terminating the network devices. So here. So actually,
And from there you can send events or publish the events to the controller from the gateway.
and that's controller hierarchy. Controller, which is doing the log, the controller which is doing the application logic, and the controllers which are doing the protocol logic.
There could be one possible deployment. I don't think we should mandate this kind of deployment.
Not for every scenario, but I'm just talking, if you want to build a very highly scalable.
If I want to build a very highly scalable platform for the controllers, I would build it that, yeah, you are able to run everything in the single node, but you could move separate services of that controller to separate nodes.
Yeah, with the proxy you can actually terminate
Yeah, so basically you moved from your monolith architecture and monolith controller to the microservices controller.
Yeah, exactly.
Let's solve the 3-node cluster first.
So Moiz is for the 3-node cluster. I would be more interested in solving personally. That's my personal opinion, not as a MDSAL committer or project lead or something like that. My personal is moving to the microservices. Like you mentioned, I have a different nodes doing different things.
Exactly. So it will be a focus in that area. I mean, because if the node where it is serving as a proxy,
But in order,
it's going to crash.
okay,
It's going to be overloaded.
okay, but in order to go there, we need to scope ourselves. Usually, these sessions originally were intended, the previous session and this session were by the authors of these sessions were intended to figure out how we can provide application clustering or all the services which are promised by the MDSAL for major southbound protocols based on the Lithium work. Lithium compatible using what is already there in the Lithium with adding some glue on top of it. The second discussion, which will be happening also, is where we want to take it in the beryllium, boron, and next. There are two separate scopes of the work. And we need to keep it focused in order to not let us go out in the wild
But can we put,
with the solutions.
but can we put the building blocks in beryllium and maybe achieve it finally in boron?
Yeah. Actually, I want to aim for that, to have some building blocks for the deployments like you mentioned, that I scale different applications differently. And I have a termination, I have gateways for the southbound plugin terminations, gateway. Yeah, and now the various nodes in the controller takes various roles. So your controller is much more, it's not anymore tightly coupled cluster of similar nodes one to one. It's a federation of the controllers or hierarchy. And I want to take that to that direction over the time. But we cannot do everything from scratch now.
So what are we doing again for lithium? I'm sorry. I think I got lost.
So we didn't get to solution yet.
Okay, good. So shall we talk about that? Because I think that's important. Getting
Talking almost like in terms of what BGP did, right? Federations and route reflectors.
So it's not a federation in common sense. It's actually the data architecture here is your application, and that what was mentioned before, cluster unawareness. Your application here, which is running OpenFlow, and was written, for example, let's imagine OpenFlow, NetConf. They are not similar, but let's assume similar problem. I have something which terminates these TCP connections and provides the so-called southbound plugin. I don't like the terminology, but okay. It provides the southbound plugins, may run in your JVM, in one JVM. That's what we have now. And over the time, you may want to run it in somewhere else because your application requires a lot of CPU power, and protocol termination points requires special amount of the CPU power for some set of the connections. And what this is talking about is much more like about location unawareness, that MDSAL or clustering services here, this is not tightly coupled cluster. This is not anymore, since you have different services different. It's not yet federation, but you are basically doing the microservices. Here, it is similar for you. You are still writing to the data store, but the data store for the OpenFlow plugin is located here, and this one acts on it. So still, it's a tightly coupled cluster, but it's not doing one node is similar to the other. You have a specialized nodes in your cluster, and the glue, which is MDSAL plus clustering plus akka, makes that possible. Actually, akka, for example, also, which is clustering technology, doesn't require you to run the same services on all the nodes. Actually, akka promotes running different services on different nodes. There is a pattern which is cluster-wide singleton in akka.
If the OS plugin and the MDSAL are communicating
So actually,
Running different nodes.
so actually it's different. The plugin uses MDSAL to use akka. So and that actually leaves us we are not tied into the akka. So you could change the clustering technology underneath or that communication technology underneath based on your deployment and use case, if you have resources to implement MDSAL APIs. But MDSAL is not one implementation. MDSAL is always a set of the communication patterns and different implementations. I mentioned itself, NetConf is a remote MDSAL. NetConf itself is implementing MDSAL APIs, but different than clustering. It's implementing the MDSAL APIs in such a way that it delegates all the calls, it's translated to the NetConf message, and sends down to the buyer and responds you back. And that could be done using the RESTconf and other technologies which are available. For example, there is an effort which is exploring remoting of the MDSAL using the AMQP. So using the message bus technology underneath instead of akka. And yeah, that will be the deployment specific option, which probably, yeah, really depends on your deployment. And depends on your scaling numbers and everything. But what MDSAL is trying to achieve is to have that simpler APIs, how to communicate with the other plugins which may be located somewhere else. Or implemented using different APIs, using not binding generated APIs, using DOM APIs, or delegate to the remote. So MDSAL actually is doing these proxies already. So once you are invoking an RPC, and that was mentioned in the OpenFlow plugin, so MDSAL has some of these technologies already in the place. When you are invoking the OpenFlow plugin RPC on the node 1, and the device is, and the OpenFlow switch is connected to the node 3, it actually delegates that and uses and transports the RPC to the node 3, and that one does the work for you. So some of the technologies are already applied in the 3-node cluster, and could be used into the transition to this model over the time.
So Tony, what do we plan to do for the 3-node cluster?
NetConf.
NetConf, yes. What are we planning to do?
All right, let me talk about what is my solution. Okay. Then we can go into this. I think Tony doesn't like it because it's not purely the way it should be in Beryllium, right? So it's actually pretty simple. So you have 3 nodes, 3 controller instances. And from the northbound, using the RESTconf interface, you're going to like mount a NetConf device, right? So when you do this, what we will do is the request comes over here. So we actually can connect to this NetConf device, get its schema, and load it on the controller. So now, like any application within this controller instance can actually go ahead and invoke an RPC on this NetConf device, or it could do data changes or whatever, right? So that is all well and good. This we can do today. What needs to happen, however, is when you mount this NetConf device over here, that same configuration needs to be sent to all the other instances in the cluster. And once it's done there, then it goes ahead and mounts these devices too. So all the instances mount the device.
What configuration do you mean?
The configuration of the NetConf connector. So basically, you configure all the free.
Exactly.
Yeah.
So they all mount to it, but only one of these instances has to be the master. So first of all, you don't write 3 nodes in inventory. You write only 1 node in inventory. And the second thing is you want only one of these connections to be master connections. So let's say this was the master connection. Now any notifications generated by this NetConf device will only come on this particular instance. Does that make sense?
So it's
Notifications come this
never
way.
going to be active.
It's not going to be active, it's going to be only one instance active. However, if let's say you try to invoke an RPC using RESTconf on this device, what we could do is we could temporarily open up this connection and do the RPC on this node and terminate the connection. So this is
Except there is one other thing in the NetConf, and some RPCs are tailored to the session on which you are sending them. And that's, for example, the notification create subscription RPC, which then starts sending the events on the
on this node.
on the one on which that RPC was invoked. NetConf is sessionless, is session protocol. It's based, and everything is based on the session.
So if I invoke an RPC from here, I might get notifications over here. Is that what you're saying?
Yeah.
What if I terminate the connection? Then I won't get the notification over here,
No,
right?
you will not get the notification here.
Okay, so I will miss out on
It's everything per session. Every state which you are introducing, except committing the configuration, is per session. Regarding the notifications mostly.
How much time does it take for the notification to arrive? I mean, can we assume something over there or not?
It may take the moment. It may take 5 minutes. So
Okay, what's the downside to this? If I make an RPC request from here, the notification can never arrive over here, even if I have all active connections, let's say?
It will never arrive there. It will arrive on the same channel. Actually, you have a similar requirement in the OpenFlow plugin, but reverted. If you send the packet in on some channel, you need to send the packet out on the same channel. The controller needs to respond to that packet in on the same channel if your response is going to be packet out.
Which is fine over there, but
yeah, but here is also tailored to the session.
in this case, you're saying this is an RPC request and a notification will arrive because of that.
Yeah, you could send an RPC request, which is RFC 5277, create subscription down here, but that subscription is only for that one session. That session could create separate subscription with different.
When you say RPC request to do a subscription, that's
So-
specifically an RPC request for subscription.
Yeah, so you could. So in the NetConf, you need to provision first state to the device to send the subscription, which is a create subscription model. So you need first send an RPC for device to start sending you events.
Okay. So then it's one more.
Okay. What do you mean the device changed state? Changed. You need here in the NetConf, because NetConf is proxy actually, need be very specific. If the device state change is that NetConf started exporting a new model, all the 3 nodes currently, with current implementation, will reconnect or drop the session and reconnects in order to download the new schemas and to start with the new schema context which changed. If the configuration on the device changed, it's not for the controller. We are doing a proxy, so it means when you are reading data, we always go and fetch them from the device. And when you are writing, we always go directly and send. So if you imagine the MDSAL transaction, which is write, submit. Actually, as you are invoking that methods in the NetConf use case, it's translated. That's why I'm saying NetConf is also the implementation of the MDSAL. They are implementing same APIs as the clustering is implementing. Is that your write actually translates to the edit config message, which is directly at the moment is sent to the switch. So each your application, what you are doing is edit config, edit config, edit config. And when you hit the submit, we send a commit message to the NetConf device. So only state which MDSAL is maintaining, which is held in the controller about the NetConf device, is actually the session, the credentials which we need to use to connect to the device, and the list of the models which were announced when the connection was initiated. And if we are connected or not. Every device which you are pushing to the NetConf is just a proxy. Everything is stored at the NetConf device.
Don't you use the schemas from the device in RESTconf as well, basically, to validate the message?
Yeah.
All right, Tony, here's a question. So let's say I do a subscription over here from controller instance 2.
Okay.
And controller instance 2 dies. Then what happens? Now anyway, you're not going to get...
No notifications are going up. Yeah.
So this is the same thing which we're talking about. Where, like only case here is if this is alive, I still miss notifications because this connection is toned down.
Yeah.
In my case, where you have connections come on.
So what happens if you make a subscription and then a session? The session actually connectivity goes down and then it's reestablished.
Your subscription is that. Subscription is bound to the session.
So you clearly, the client needs to maintain
Yeah, and there is an utility class which maintains the subscriptions, listens on the events, and resubscribe if the session goes down. And unfortunately, there was a wrong name chosen for it, but that's the event source API and event source topology, where you could specify subscribing to all the NetConf devices and maintain the subscription. So if the session goes down and goes up, it goes and resubscribes on this particular session. But this is not implemented into NetConf connector itself. It's an application running on top of the NetConf connector. Because if you look into the RFCs, RFC 602041, which is NetConf, doesn't say anything about notification subscription. Notification subscription is a separate feature capability, so the core NetConf protocol doesn't know about how to subscribe.
So shouldn't that application actually cluster or share the information about the other nodes?
That additional application? The additional application is actually storing that information in the network topology, in the data store. So it has the information where to subscribe and when to subscribe.
So basically, any node from that set of three could, if it's determined.
Are you saying that there is like an RPC for subscription, or
Yeah.
subscription is a?
There is an RPC for subscription in NetConf.
And
52? Yeah, 5277, yeah.
and when we subscribe, you're saying that data actually gets stored in the data store. The
No,
subscription
no,
gets
there
stored-
is the other application, which provides you higher level APIs, which is subscribe to all the NetConf devices to this topic, to these subscriptions. That's it was incorrectly called originally message bus, but that's the event source thingy, which actually goes and then listens if the NetConf device disconnected, connected, starts sending that subscription messages again to maintain the flow intention of the application. So the application itself doesn't need to go and listen for the NetConf sessions in order to resubscribe, to resend that RPC for the notification. But that isn't implemented directly in the NetConf connector because RFC 5277 is probably just one way how to do the subscription. Maybe some other vendors have their own ways, and that's why we provided an application on top of it, which is framework, which allows you to implement the SPIs to have a common subscription model for NetConf and probably for the other protocols.
Okay, that's fine. So let's say we have that application running over here,
Yeah.
and you register, like you execute an RPC, and that application actually stores that as configuration into the data store. Then why can't I invoke the RPC from here if I have a listener over here?
So if you invoke the RPC from here, you start receiving notifications here,
Which is fine, which is what I want because this is the master.
and where the application, which actually triggered that, is running.
That's running over here.
Okay, and now we need to get the notification here.
So how many sessions will you be having? One?
There's only one active session. There's a master session on all these sessions are not
Okay.
actually used.
Yeah, but you need to now deliver the notification here.
But where's the notification data? I mean, it must be.
What happens to the notification? Why does the notification need to be delivered over here?
Because application which actually consumes that notification is here.
No, because it's a symmetric system, right? So the same application is running over here as well.
But now you are assuming, and I'm not.
I am assuming.
Yeah,
It's a
I'm not saying about the event source topology and that application which used event source topology to that. And now we are coming to the assumptions about how applications works. If it's a symmetric system, the applications could safely do their work only if they are sharing state. And you are not. And notifications and RPCs are local state, which is not captured by the MDSAL. It's not stored by MDSAL. It's not replayed by MDSAL. And if the application creates some state internally, some local state, based on that,
Yeah, that's different.
that's the problem.
I mean, okay, applications need to be.
You can have multiple apps being active on different nodes that actually all talk to the network, NetConf device and receive the same or maybe different notifications from it.
Yeah, but that's fine because if the notification arrives over here and the same app instances are running on
You
this
cannot
node,
guarantee that the app will be active running on that node. It can be running on any other node.
So
we can assume that
So
Is there
For
any
that
node
particular
where
entity.
it's acting sharp?
No, it's only for that particular entity. So for that, for network like netcon device 1, it is active on controller instance 1. For netcon device 2, it is active on controller instance 2. We can do that, right?
Well, you could do that, but not with this solution, I think.
Why not?
You can assume it's active as long as he has control of which one is the master.
Right.
Is that even
And
provided?
exactly, we do have a way to actually choose a master for an entity. I mean, we are going to make that available. So then you can do that.
Critical piece.
Yes.
Yeah. The
Actually, we talked
application
about it.
has power over.
We talked about it.
Why can't you have both running a session, both of them checking each other's data and synchronizing? That's carrier grade, right?
How do you check each other's data?
What's that?
How do you check if they are islands? Then how do they check each other's data?
That's that smart layer of people who are gonna say, here's what the data means, and you can synchronize those objects, make sure they're the same.
I don't exactly know how that would work, but
If
You got it?
if I ask for
I understand.
okay.
what's the state
Yeah.
of Bob? One says Bob is happy, one says Bob's happy, they actually match your sync. One says Bob is happy, one says Bob is sad. Which one came last? That's probably the one that's important. What's that?
Basically, all right. What you're saying is
I'm just trying to keep it abstract enough
Okay.
so that we're not worried about the details. But I'm just saying, what's the issue? If you want, instead of having just one guy sending this stream, and then if he dies, you got this window where, a minute you don't have data. Why not have both go?
there's only one way to synchronize, and that is by using the data store. So
I
somehow
agree.
you put some data in there. Both of them are putting the data in there,
So we-
and one of them will win, one of them will lose,
Yeah.
right?
Yeah.
And if you say that,
And isn't that an interesting thing? If the datas are different, that's actually kind of interesting. Maybe an application would want to know about that.
Yeah, one will fail.
one will fail.
Well,
One-
often, one of the scenarios
the
that
first one
happens
will
is
win.
you think you're getting your data from Bob, you're actually getting it from Ted, right? How do you detect that? Unless you're doing them both at the same time.
It seems like everybody has a slightly different concept or a slightly different thing that's important to them about NetConf. Maybe, most people don't care about subscription, they just want to get
Yeah.
configuration, right? So it almost seems prudent to write down the restrictions that we need to design within and get that sort of documented to make sure, we say, these are the restrictions we're designing within. We want to be able to do gets to a mounted Yang model on any cluster node and get back my results without having to mount that device on all three nodes, right? And that's a pretty simple use case that we'd want to support. I mean, just throwing off other ones, there's this whole idea of getting notifications, and I don't know what the restrictions and what the use cases are around that. I mean, ideally it would be if a node goes down, I would want to continue getting my registered notifications on the next node. I don't know, from a user's perspective, right? So
Actually, I don't really know whether that's what you want.
Well,
Tony says that is important, so I'm saying I agree with Tony. I don't know much about NetConf. I'm just thinking in terms of, okay, this problem needs to be solved.
Yep.
What can I do to help solve this problem?
Yeah,
I'm just
like-
trying to determine that. So,
And I think
he's the
these-
NetConf master.
No, I'm not.
These things it's important for us to sort of say, what are the problems we're trying to solve? Like, there was the whole question about performance, right? I think in the end, we just need to pick a number and say, we're trying to solve at this performance level right now. And just so that we can get some grounding and 'cause right now, we're throwing around different things and everybody's swapping around to different discussions. I think if we focus our discussions on, let's brainstorm the requirements and then try and pick one and focus on it and then pick the next and see how we can roll it in.
Okay.
We might actually get to a design or some.
Do you have an idea of what is the requirement? Exactly. You think you would give? I mean, should notifications work across the cluster?
Can we perhaps,
Notifications will be the problem because everything else is just faster.
yeah, because we're focusing on these notifications, but I think the configuration, the HA for configuration.
So, where is the problem in HA for configuration with Moiz idea?
We don't have it, right? We don't have anything.
So, with my idea, that would work.
So the first thing which is missing is, you want a NetConf session available from all the devices. Two ways to achieve it. One, all the NetConf devices are connected. you have a measure of the connectivity. Second, you route to the node where there is. There are pros and cons in both of the solution.
I like the second one better because that will help us scale the number of devices we're controlling.
But now you're talking about solutions as opposed to requirements.
So requirements are there.
So do we all agree that the two things we want are be able to do a get to,
So
to NetConf device to one node in a cluster, do a get config to that Yang extension mount on any node, have it succeed. And
that's the basic requirement.
that's the basic requirement. Do we just want to focus on that requirement, or do we want to see if there's other requirements that?
So
that
get
we
and
have?
change configuration, basically, that's it.
So just do a get to the.
Get, edit.
Configure on one node, nodes mounts.
So you configure on one node.
Configure on one node.
You have to kind of implement the technical specification basically in its entirety, which is get set configuration with the RPCs and do the notifications. Without notifications, then don't know that use.
So ideally, I think any operation I can do on the empty set iteratively, I want it to transparently work on the mounted as well.
Okay.
Right? Like just like I can do get and set, I can do RPC, or I can get notifications. I want it to be transparent that it is mounted.
Okay.
Okay.
And how do you choose a master?
The same leadership service that we talked about, the open flow clustering.
That's now. Future will be different.
In the future, how will it?
I would choose mastership data driven, so I would try to collect the data where the applications are located which are using the NetConf server,
Yeah, that's
and the
strategy.
master should be,
That was the
yeah.
strategy we talked about. So leadership is going to be based on custom strategies.
let's call it that way. Actually, we will get to the point.
Once the API is
We will
clear-
get to the point that actually each application you are writing is just a topology, and you need to figure out the effective routes in that topology, and then you render that topology into the underlying topology, which are your containers, which are your VMs, and you got.
That's too abstract.
Yeah.
I think that's too abstract.
Your application is always layer 7 topology, and it should never be different.
I think we're technically
Yeah.
at the level, but what did you want to get at? So the first requirement.
I think the requirement is if you have
Two ways of doing it, right?
No,
Yeah.
forget about the two ways. I mean, I don't think even with your way the notification thing is going to work, right? Proxy, no, not yet.
We'll figure out that at the table. Okay. We are top of the hour?
Yeah, we are.
Oh, we are 2 minutes.
We have 2 minutes again.
No, we are 2 minutes over already.
We need to continue this, but I think you need to explain what you would do for Beryllium and Boron. Because it looks like whatever solution I have, that won't solve the transparent. Basically, it's like just